This course will guide you through the construction of a control system. The deliverable is a terrarium controller. Along the way, you'll learn a great deal about useful technologies such as the Node-RED programming environment and MQTT. Ideally, you want to complete this course because you want to learn Node-RED and MQTT and extend your existing knowledge of the ESP32 and the Raspberry Pi. Consider this project as a powerful tool because it provides you with clear and verifiable objectives. In this lecture, I'll talk about the deliverables so that you know what you'll build and the main learning outcomes. I'll also talk about the skills that you will need to have before you begin. Let's start with the project deliverable. By the end of this project, you'll have created a control system for a terrarium. A terrarium is simply a container in which you add some soil and a small plant. Personally, my motivation for this project was not the terrarium itself. I'm not very good with plants and only have limited interest in being a gardener. But when I combined plants with technology, things became much more interesting. I decided to do this project because it gave me the opportunity to work with several technologies that I find very interesting, and more about this in a moment. The deliverable of the project is the terrarium controller, which consists of the hardware and the software. You can see the hardware in the photo in this slide implemented on a breadboard. You can also choose to implement it on a PCB that I've designed. The software part of the controller consists of the main logic implemented in Node-RED and the ESP32 sketch. Node-RED is where all the decision-making and logging takes place, and the ESP32 sketch is simply there to report sensor values and execute decisions from Node-RED. The layer that connects the two software components together is the MQTT Mosquito broker. Okay, now that you know what you're about to build, I'll explain what you learn along the way, which I think is a lot more important. You learn how to use Node-RED. Node-RED is a powerful graphical programming environment. It's built on Node.js, a JavaScript framework from where it got its name. Node-RED is very good in enabling hardware devices, small and large, APIs, and all kinds of online services to work together. I found that its learning curve was relatively gentle, and once I got my head around how flows are assembled, configured, and executed, I was able to quickly create prototypes. Because Node-RED is lightweight, it runs perfectly well on any Raspberry Pi, even the original. In this project, I used an old Raspberry Pi 2 that I had forgotten in one of my drawers, and I encountered no issues at all installing the new Raspberry Pi OS and running Node-RED on it. Node-RED actually comes with the Raspberry Pi OS, so you don't even need to install it. By going through this project, you'll become skilled in using Node-RED in a variety of control projects. You learn how to use the Raspberry Pi as the brain of these projects and implement elaborate control flows. As I mentioned, Node-RED is designed to be light on resources so that it can be used on low-power computers. It's also designed to work well with MQTT, a transport system that, like Node-RED, is very light on resources as well. Let's have a look at MQTT now. MQTT is a way of messaging that allows clients to talk to each other using the publish and subscribe model. The idea is simple. If a client wants to send data to another client, it will publish the data to a topic that is maintained by the MQTT broker. Think of a topic as an address. The client essentially will post or publish the data to this address. When another client wants to get the data, it will subscribe to the same topic. The MQTT broker operates as the intermediary between publishing and subscribing clients. Think of it as the server in this setup. Many clients can subscribe or publish to the same topic, making it possible to design all kinds of topologies you can think of. The MQTT broker sits in the middle of these communications. When a client publishes data to a topic, the broker will immediately push it to any client that has subscribed to the same topic. For the clients, this means total freedom from having to maintain information about who the data should go to. As an extension for us, the Terrarium controller designers, we don't have to worry about programming complicated client relationships in the Node-RED flow or the ESP32 sketch. All we need to do is to know which topic a client should publish or subscribe to, and the broker will take care of the messaging. MQTT is a technology that is very useful to IoT projects, and by completing this Terrarium project, you'll gain hands-on experience in using it. And with Node-RED, you have a complete solution for control and messaging between lightweight clients. Because MQTT is lightweight, it works very well on low-powered Arduinos like the Arduino Uno or the more powerful ESP32. Although in this project we are using the ESP32 mainly because I wanted a simple way to connect to my Wi-Fi network, you can use the exact same knowledge to implement MQTT messaging in any Arduino. A project gives us an opportunity to branch out and explore. While my primary learning objectives were Node-RED and MQTT, a more complete deliverable required adding additional components. I decided to use Google's Drive and Sheet APIs and if this and that as representative technologies of what is available to makers right now. Both technologies are mature and very useful, no fluff there. Of course, Node-RED made it easy to interface my flows with both. Integrating these two in the Terrarium controller project made the project itself much more complete, but also proved to me that there is massive potential for growth. I feel that I'm only confined by my imagination and time. For example, think about what might be possible if I somehow integrate TensorFlow in my Terrarium controller project. TensorFlow is a public service by Google for creating machine learning models on the cloud. Imagine using TensorFlow technology to get artificial intelligence to learn using sensor data from your terrarium, which can then be used to automatically control it for optimal growth of your plant. Many of the elements of utilizing technologies such as TensorFlow are same or very similar to using a regular Google API or if this and that. Last, what do you need to know before starting this project? So, to complete this project, you do need to be comfortable with a few technologies, and I have listed the minimal knowledge requirements in this slide. If you are watching this video, chances are that you are ready. In short, if you completed my two other courses, ESP32 for busy people and Raspberry Pi full stack, then you are ready to start with this new project and challenge. But if not, I suggest that you do some work on these two courses first. You don't need to complete them, but at least go through the first 3 or 4 sections to get up to speed with things such as installing the operating system on the Raspberry Pi, getting comfortable with the command line, and understanding how to use the Arduino IDE with the ESP32.